Hello, this is Jack Jackson. In this video, we're going to continue to talk about measures of central tendency. In our last video, we talked about how to compute the various measures of central tendency that we've been talking about. And in this video, we're going to continue to talk about these same concepts, but I'm going to ask you a series of questions to see if you really understand deeply what these concepts actually mean. So I'm going to ask you these questions, and as often in my videos, I'm going to ask you to pause the video, answer the question, and then press play to continue to see my answers. So the first question is, which measures of central tendency have we discussed, and which ones of these are the most commonly used? Press pause. And now that you have your answer, you're back. Well, we've talked about the following measures of central tendency: mean, median, mode. We've also talked about mid-range and mid-quartile. So we have 5 different ones, which you see listed up here. For example, in our previous video, we looked at this dot plot of this candy sales, and we computed all of those. Now, the most often used one is the mean. That's the most often used measure of central tendency, and the median is the second most commonly used measure of central tendency. In fact, a lot of times if you'll give both the mean and the median, those are together can help you describe the center pretty well. The mode's also pretty often used as well. So often we'll give maybe all 3 of those measures. Now, the mid-range and mid-quartile are not used as often, and mainly we're using them here to compare and contrast with some of the more commonly used measures of central tendency. So number 2 question, what is meant by the word average? Press pause. Okay, well, it kind of depends on who you talk about what is meant by the word average. So sometimes some statisticians often use the word average to refer to any of the measures of central tendency. So the mean, median, mode, mid-range, and mid-quartile are all called averages of a type. But most people, or a lot of people anyway, if they refer to something the average, as if there is only one average, then they are almost undoubtedly referring to the mean or arithmetic mean. It's best to specify explicitly which of the measures of central tendency, or averages, we're using to identify the center of distribution, and use the term average sparingly. But I would say most people, when they say average, they mean the mean, but some people mean any measure of central tendency. All right, let's see if you think about how these things are computed and see if you can answer this next question, number 3. Which of the 5 measures of central tendency absolutely have to be one of the data values, and which ones could be something that never actually occurs in the data set? Think about that and come back when you're ready with your answer. Press pause. Well, actually, there's only one that absolutely has to be one of the data values, and that's the mode. And of course, the mode is the one out of all of them that may not exist. Remember, the mode is the single most often occurring data value. Some people will also define there to be 2 modes if there's a tie for the most often occurring. But basically, if there's not 1 or maybe 2 values that occur more often than any other, we say the mode doesn't even exist. So there might not even be a mode. But if the mode, if present, is the only one that has to be one of the data values, because it's always an actual data value that occurs more often than anything else. Now, in certain cases, for example, if there's an odd number of data value, the median has to also be one of the data values, because there will be, remember, you put the median to find that, you put the data in order from smallest to largest, and the one that's in the middle of that ranked list, so that there's an equal number above and below that particular data value, then that will be the median, and that's actually a data value. So if there's an odd number of data values, then the median will be one of the data values. But if there's an even number, then you average the 2 in the middle, which might be between two data values and not be one of your data values. Of course, if those two happen to be the same thing, then their average is the same number, and of course that is a data value. So in the even number case, the data values, when you have an even number of data values, the median may or may not be one of the data values, but if you have an odd number of data values, then for sure the median is one of them. The mean, mid-range, and mid-quartile, again, might or might not be the actual data values. Okay, so the mid-range and mid-quartile, remember, you're averaging two things. In other words, you're adding them up and dividing by 2. And so when you divide by 2, you could get something that falls where there's not an actual data value. In fact, it's even possible that the mid-range or mid-quartile might give you a value where there's not even another one, really close to it, possibly. The mean, which is the most often used one, is often a data value that may not or perhaps even cannot exist. For example, it might be that a group of people have on average, for the mean, of 2.5 children. But of course, nobody can actually have 2.5 children. Okay, so it might not be a data value. It might even be a value that doesn't even make sense. Okay, now how about number 4? Which of the 5 measures of central tendency absolutely have to exist and which ones might be undefined? Press pause when you're ready. Come back. Okay. So, well, I think we just answered this one already. The mode may not exist. Okay. But all of the other 4 must always exist if you have a quantitative data set. The mean, median, mid-range, and mid-quartile always exist if it is a quantitative data set. The mode might not exist for if there are multiple ties for the most frequently occurring data value, there's not a mode. Or, for example, when no data value is repeated, then there would not be a mode. Now, the mean, mid-range, and mid-quartile are only meaningful when the data is interval or ratio data. Okay, they're not really truly meaningful, or certainly not fully meaningful, unless that is the case. The median is meaningful when the data is at least ordinal. As long as you have an order to it, then you can compute a meaningful median. So if the data is ordinal, then really you should only be looking at medians, not any kind of, well, even if you could even compute them, what might be meant by mean, mid-range, or mid-quartile, or they may not be computable. If the data is nominal, the only measure of the central tendency that really makes sense is the mode, provided it is defined. So it kind of depends, the answer to this question really kind of depends on the type of data you have. So if it's nominal data, the only one that even makes sense is the mode. You can't really can't compute the others, and then the mode may or may not exist. If the data is ordinal, then the median makes sense, and so it'd be the median and the mode would make sense. The mode may or may not be defined. The median would be defined then. And then if the data is interval or ratio level, then the median will exist, the mean, mid-range, and mid-quartile will exist, the mode may or may not exist, and all of them that exist have meaning in that context. Okay, next question. Which of the 4 measures of central tendency might be closer to the maximum than the minimum? And the answer is all of them except the mid-range. The mid-range by definition is exactly the same distance from the maximum as it is from the minimum. The mode, mean, median, and mid-quartile all may be closer to one extreme than the other. It may be closer to the minimum than the maximum, or closer to the maximum than the minimum. In particular, the mode can be basically anywhere, and the mode could easily be one of the extreme values. The mode could actually be the maximum. Think about it a minute. If the maximum value is the one that occurs the most often, then that's the mode, in the same way that could occur for the minimum value. Well, that partially answers the next question. Which of the 4 measures of central tendency might be at one of the extreme values? Well, the mode can certainly be easily anywhere between the extreme values, including being at one of the extreme values. So in this sense, the mode is not always really a middle or central value, but rather a typical value. However, it is still classified as a measure of central tendency. The mean, median, mid-range, and mid-quartile are usually not the extreme values, but there are some very highly unusual cases where they could be the extreme values. So, for example, the only way you could get the mean and mid-range to be one of the extreme values is when all the data values are the same. So if you get a data set where every single number is the same, then of course all these measures of central tendency are that one data value. And that's the only way you can get the mean and mid-range to be one of the extreme values. And for the mid-quartile, the only way you could get it to be one of the extreme values is when over 3/4 of the data is at one of the extreme values. Again, that would be high. Both of those cases are kind of highly unusual. And a little less unusual, but still pretty unusual, only when over half of the data is one of the extreme values will the median be one of the extreme values. So basically, for any kind of normal kind of data or usual kind of data, the mean, median, mid-range, and mid-quartile basically cannot be the extreme values. Only in these highly unusual cases could they possibly be extreme values. But the mode could be almost anywhere, and it wouldn't be, well, it might be unusual, but not unheard of at all to make them to be the mode to be one of those extreme values. Which of the 5 measures of central tendency depends only on the extreme values? Okay, and the answer is the mid-range. The mid-range depends only on the extreme values, only on what the maximum and minimum are. In contrast, the mode is the one that occurs the most frequently, and the mean, median, and mid-quartile to some extent depend on all the data values in the set. Certainly the mean does, because you're actually adding up all the values. The median is something about how those values are distributed throughout there, and the mid-quartile has to do first with getting the quartiles and then taking halfway between those. So so they all are influenced, at least to a certain degree, by other values besides the maximum and minimum. But the mid-range, that's exactly what it's determined by. Only the extreme values. Okay, now how about this one? Which of the 5 measures of central tendency are sensitive to outliers? And that is sensitive to or highly affected by extreme values. In other words, suppose that we have a data set called A. Data set B is exactly the same as data set A, except we only change one value, making the maximum much larger, or similarly we could make the minimum much smaller. Which of the 5 measures of central tendency will be affected by this change of this one far out there data point, which we would call an outlier? See if you can answer that question. And let's think about it. Increasing the maximum or decreasing the minimum will have absolutely no effect on the value of the median and the mid-quartile, assuming the other values aren't changed. So even several outliers or an extreme outlier will have no effect on these measures. And unless the mode happens to be at the extreme values and be one of those value points that was changed, changing extreme values will also have no effect on the mode. So we say that these measures are not sensitive to outliers. Okay, so the median, mid-quartile, and mode are not sensitive to outliers, are not sensitive to extreme values. But now think about this. In contrast, changing just one extreme value will change both the mean and the mid-range. In fact, the presence of even a single outlier can often significantly shift both the mean and mid-range. We say that these measures are sensitive to outliers or sensitive to extreme values. And when outliers are present, these may not be representative measure of the center because it's not really the center of the data set in some sense, because that one data value in a way maybe shouldn't be part of the data set. It's very unusual, that outlier. So we have to be careful about this. And this is actually a pretty big deal here. So this is why it's very useful to not rely just on the mean, even though that is probably still the most, not probably, it is definitely the most commonly used measure of central tendency. But in many cases, particularly when we have outliers, the mean is not necessarily the best measure. Probably the best way to do is to report multiple measures of center. Under what condition will various measures of central tendency be the same? If the data is exactly symmetric, which we would say has zero skewness, then the mean, median, mid-range, and mid-quartile measures of centers will all be absolutely identical. In this particular case, the symmetric case, for every data value above the center, there's a corresponding value below the center that's the same distance from the center. If the data is close to symmetric, then these four measures will be near each other. So if the mean, median, mid-range, and mid-quartile are all very close to each other, the data is very close to being symmetric. Maybe not perfectly symmetric because they may not be perfectly the same as each other, but if they're pretty close, these four measures of central tendency are close to the same, then the others will be close to the same. So now even in the case it was perfectly symmetric, the mode could still be very different from one of the other measures. So the mode could still be, maybe it's bimodal, even if it's perfectly symmetric, it could be bimodal with something way out left of the other measures of central tendency matched by a point way out to the right, the same distance. But if it turns out that the mode is also the same as the mean, median, mid-range, and mid-quartile, if all five of these are the same, not only is it symmetric, it's mound-shaped so that the highest point is in the middle, and particularly if you have lots of data that is sort of close to the center and then decreases as we go off away from the center, left and right, we call that symmetric mound shape. And so that is close to symmetric with the mode being near the other measures of central tendency, and values decreasing frequency as they move away from the center. So mound-shaped data actually is quite common and is approximated well by something we call a normal distribution or a bell-shaped curve, and we'll study that in depth later in the course. Sometimes your textbook will talk about, some of the textbooks talk about the empirical rule. They'll discuss that at somewhere near where we are or in the variability section. If you talk about that empirical rule, you're assuming that the data is from a normal curve, which is a mounded bell-shaped symmetric about the mean, and the mean, median, mid-range, mid-quartile, and the mode are all the same. Okay, I think that concludes this little set of exercises on basic concepts of measures of central tendency.